A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. You know, Herman, I was looking at some old folders on my hard drive the other day, and I found a script I wrote in early 2024. It was this convoluted Python mess just to automate sorting my downloads. It took me 3 hours to debug a simple regex string. I remember staring at the screen, questioning my entire career, because I couldn't remember if the parentheses needed to be escaped or not.
I remember that. You almost threw your monitor out the window because of a misplaced backslash. It's that classic regex blindness, where the more you look at it, the less it looks like language, and the more it looks like a cat walked across your keyboard.
I did. But today, I could probably just whisper that requirement into a terminal, and a model would not only write it, but handle the edge cases I didn't even think of, like what to do with duplicate file names or hidden system files. It's wild how fast the floor has moved. Today's prompt from Daniel is about exactly that. The state of autonomous coding as measured by the SWE-bench verified leaderboard. We're looking at the gold standard for how well AI can actually navigate a real codebase and fix real bugs.
This is essentially the Olympics for AI software engineers, and the numbers coming out of late March 2026 are staggering. We've gone from models barely being able to find the right file to models like Claude 4.5 Opus hitting nearly 80% accuracy on human-verified GitHub issues. By the way, fun fact, Google Gemini 3 Flash is actually writing our script today, which is fitting since Gemini is currently a massive player on these leaderboards. It's like the model is reporting on its own sports highlights.
It's a bit meta, isn't it? An AI writing a script about how good AI is at writing code. But let's look at that 80% number. Claude 4.5 Opus is sitting at 79.2% on the verified set as of December 2025. On the surface, that looks like we're 5 minutes away from the AI just taking over the entire sprint board. But Daniel's prompt points out that there is a massive amount of nuance behind that single percentage. For context, a human software engineer, given the same environment and time constraints, typically scores around 90 to 95% on these specific tasks. We are getting remarkably close to the human baseline.
There really is a lot under the hood there. If you look at the historical progression, it's a vertical line that's suddenly starting to curve. In April 2024, GPT-4 with the original SWE agent scaffold was scoring 22.4%. People thought that was a miracle at the time. Then Claude 3.5 Sonnet came out and jumped it to 33%. By October 2024, we crossed the 50% threshold. Now we are knocking on the door of 80%. But the leap from 73 to 79 took almost twice as long as the leap from 30 to 50.
We're hitting the wall of diminishing returns. It's like a sprinter trying to shave a millisecond off a world record versus a middle schooler improving their 100-meter dash by 3 seconds. The easy bugs, the low-hanging fruit, typos, and simple logic errors are gone. What's left on that leaderboard are the weird deep-seated architectural bugs in Django or matplotlib that require a genuine understanding of how 1,000 different files interact.
But wait, how does the benchmark actually work? Is the AI just guessing?
Not exactly. It's given a folder containing the entire repository and a text description of the issue. It has to explore the files, reproduce the bug by writing a test case, modify the code, and then verify the fix. It's an end-to-end process. If it fails to find the file, it fails the task. If it fixes the bug but breaks 3 other things, it fails the task.
And that brings us to the most important realization of the 2025 coding boom: the model is only half the battle. The scaffold, or the agent framework, is the other half. You can take the exact same model, Let's use Claude 4 Sonnet as the example, and its performance swings wildly depending on who built the harness it's sitting in. With the standard SWE agent scaffold from May 2025, it scored 66.6%. But when the team at EPAM AI put their own custom agentic wrapper around it in August, that same model jumped to 76.8%.
That is a 10-point spread on the same brain. It's like giving two people the same IQ, but one of them has a library card and a high-speed internet connection, while the other is trapped in a dark room with a single textbook. What are these scaffolds actually doing, Herman? Is it just better prompting, or is there something more mechanical happening?
It's highly mechanical. A good scaffold like LibSWE agent or OpenHands isn't just sending along prompt, it's managing a file searching tool, a linting tool, and a test running environment. It's essentially a loop: search for the bug, propose a fix, run the tests, see the failure, read the traceback, try again. The scaffolds that are winning right now are the ones that have perfected the inner loop of debugging. They know how to prune the search space so the model doesn't get lost in a massive repository like scikit-learn. Think of it as a specialized OS for the AI.
I love the idea of pruning the search space, because if you just dump 10,000 lines of code into a context window, the model gets lost in the middle. It's that classic needle in a haystack problem. The best agents act like a senior developer who says, "Don't look at the database logic. The bug is definitely in the routing middleware." They guide the LLM's attention. But how does the agent know where to look without reading everything first?
It usually starts with a semantic search or grep on the keywords in the issue description. A sophisticated scaffold will look at the file tree, identify relevant-looking file names, and then peek at the imports. If tmodels.pa imports validators.pata, the agent follows that trail. It's mimicry of how you or I would navigate a new codebase. We don't read every line, we look for the scent of the bug.
And if you look at the live SWE agent results from late 2025, you see Claude 4.5 Opus hitting 79.2%. But look at Gemini 3. Pro, it's right there at 77.4%. The gap between the absolute top-tier Western models is shrinking to a margin of error. And what's even more fascinating is the cost-to-performance ratio. In the Mini V2 controlled comparisons, Claude 4.5 Opus costs about $377 to run across the benchmark. Gemini 3 Flash, which is a much smaller, faster model, scores 75.8%, only a tiny bit lower, but it costs $178. Wait, hold on. So you're telling me that for half the price you get 98% of the performance? That's the real story for engineering managers. If I'm running a fleet of these agents to maintain a corporate codebase, I don't care about the 2% ego points at the top of the leaderboard if it doubles my compute bill.
It gets even more extreme. There's a model from a Chinese lab called Minimax M2.5. It's a high reasoning model that scored 72.4% on that same controlled test. That's only 4 points behind the world-leading Opus model. But the cost? $36.
$36 versus nearly $400. That is a 10x difference in efficiency. That basically means the intelligence is being commoditized at a rate that should make the big labs very nervous. If a budget model can solve 70% of real-world GitHub issues for the price of a lunch, the era of the expensive AI developer might be shorter than we thought. I mean, why would I pay for the Ferrari to go to the grocery store when the Honda does it for a fraction of the cost?
It also highlights the Chinese lab factor that Daniel mentioned. We've seen Dubao seed code from ByteDance hitting 78.8%. That's third place globally. Kimi K2, Quinn 3 coder from Alibaba. These models are not just catching up, they are effectively parity with Anthropic and OpenAI in the coding domain. Coding is a very structured, logical task where you have a ground truth in the form of a compiler or a test suite. It turns out that's the perfect environment for these labs to optimize their training. They can generate millions of synthetic coding problems, run them through a compiler, and use that as a perfect feedback loop for reinforcement learning.
It's also an environment where you can't really fake it. You either pass the tests or you don't, but I want to push back on what SWE-bench actually represents. Because when I'm working on a project, I'm not just fixing a bug in one file. I'm thinking about how the new feature affects the API design, whether it breaks the documentation, and if the security team is going to scream at me. Does SWE-bench capture any of that big picture stuff? Like, does it know if the fix is elegant or just a hack?
Not really, and that's the big caveat. SWE bench tasks are almost entirely single file patches. They are micro tasks. You are given a specific issue description, usually a bug report, and you have to find the tiny logic error and flip a bit or add a check. It doesn't measure architectural vision. It doesn't measure the ability to refactor a whole system to use a new design pattern. It's essentially a very sophisticated version of leak code for agents. It's testing the mechanic skills, not the architect skills.
So it's the world's best junior developer. It can fix the broken button or the null pointer exception, but it's not going to sit in a meeting and tell you that you should migrate from REST to GraphQL because your mobile latency is too high.
Precisely. And there's another issue that's been popping up lately, data contamination. OpenAI actually did an audit recently on GPT 5.2 and Claude 4.5 Opus. They found that these models could sometimes reproduce the gold patches, the actual human-written solutions, verbatim from their training data. Because these are real GitHub issues from famous projects, they were likely in the training set. If the model has seen the commit that fixed the bug in 2022, it's not solving it, it's just recalling it.
Oh, that's a massive asterisk on those 79% scores. If the model has already seen the answer key, it's not solving the problem, it's just remembering it. That explains why the verified set had to be created. It was an attempt to filter out the most obvious examples of contamination, right?
The verified set involved human engineers looking at the tasks to make sure they were actually solvable and that the tests were robust. But even then, if the code is on public GitHub, it's likely in the training data. It's why the industry is moving toward SWE-bench Pro. That's a newer benchmark where they use tasks that were published after the models were trained, or they use private repositories that haven't been scraped. And on SWE-bench Pro, the scores crater. Claude 4.5 Opus, which gets an 80% on verified, drops to about 46% on Pro.
Wow, that is a 40-point drop. That tells you that about half of the intelligence we're seeing on the main leaderboards might just be very high-end memorization. It's still impressive that it can retrieve the right memory and apply it to the code, but it's not reasoning from first principles in the way a human engineer does. It's more like a student who memorized the practice exam and then struggles when the teacher changes the numbers on the real test.
And yet, even that 46% on Pro is still transformative. If an AI can autonomously fix nearly half of the non-memorized real-world bugs in a code base it's never seen before, that is still a massive productivity multiplier. We're moving into this world where the human in the loop becomes an editor rather than a writer. You aren't writing the fix, you're just approving the PR.
I think about the agent scaffold effect again. If the scaffold is what's driving these jumps, maybe the future isn't a smarter model, but a smarter environment. Like, if the AI has access to a live debugger, or if it can talk to other agents, maybe that's how we break the 80% ceiling. Imagine an agent that can actually spin up a Docker container, run the app, and see the UI failing.
That's already happening. There's a system called Augie that currently tops the SWE-bench Pro leaderboard at 51.8%. It uses a Claude 4.5 Opus backbone, but the way it interacts with the code is much more human-like. It doesn't just guess, it builds a mental model of the execution flow. It uses a plan-act-reflect cycle. It writes a plan, executes a small part, checks if it worked, and then adjusts the plan. It's essentially chain of thought, but for software architecture. It's slow, sometimes taking 30 minutes to solve one bug, but it's thorough.
It's interesting to see who's missing from the top of these lists. Daniel mentions that GPT-5 is underperforming expectations. On the OpenHands leaderboard, GPT-5 is at 71.8%. That's good, but it's not the God model everyone was predicting a year ago. It feels like OpenAI is focusing more on multimodal omni features, voice, video, emotion, while Anthropic and the Chinese labs are obsessing over raw coding logic.
It's a divergence in strategy. Anthropic has clearly doubled down on the computer use and Claude Code ecosystem. They want the model to be a literal drop-in replacement for a dev, and it shows. They hold 7 of the top 11 spots on the verified leaderboard. If you are a developer today, you are likely using a Claude-based tool like Cursor or Claude Code because the vibe of the code it produces just feels more engineered. It handles edge cases like null checks and asynchronous race conditions that GPT-5 sometimes glosses over.
Engineered is the right word. When I use some of the older models, the code looks like it was copied from a Stack Overflow answer from 2012. It's technically correct, but it's ugly. No type hints, weird variable names like Data1 and Temptivar. The newer models, especially with these high-end scaffolds, are starting to write code that actually follows modern best practices. They're using type hints. They're writing docstrings. They're thinking about edge cases. They write code that looks like it came from a senior dev at Google.
But we have to talk about the plateau Daniel mentioned. We went from 22 to 79 in 2 years. That's an insane vertical climb, but if you look at the last 6 months, the gains are measured in half percentages. Are we reaching the limits of what LLM architecture can do for coding? Is there a ceiling where a transformer-based model just can't understand? A complex system?
I think we're reaching the limits of what text in, text out can do. To get to 95%, the AI probably needs to be able to actually run the software in a persistent environment and observe it over days, not seconds. It needs a long-term memory of the codebase. Right now, every time you start a SWE-bench task, the agent is essentially born into a brand new world. It has no memory of the last time it fixed a bug in Django. A human developer gets faster over time because they learn the quirks of the system. They remember that, oh, this module always has issues with the database connection pool.
That's a brilliant point. The benchmarks are stateless. Each task is an isolated event. In the real world, coding is stateful. You know that Dave in DevOps always writes weird networking code, so you look there first. You know the legacy auth. Module is a house of cards, so you avoid touching it. Until agents have that historical context, they will always be capped at a certain level of performance. They are constantly reinventing the wheel for every single ticket.
It's also about the verification part. Even on the verified leaderboard, who is verifying the AI's fix? It's a test suite. But we all know that you can pass a test suite while still introducing a time bomb of a bug that only shows up in production under high load. SWE-bench doesn't measure performance regressions or security vulnerabilities that don't trigger a specific test failure. It doesn't check if the AI just increased the memory usage by 400% to solve a simple logic error.
Right, you could fix a bug by just commenting out the line that throws the error. Technically, the test passes. A human reviewer would catch that in a heartbeat and call you an idiot, but a benchmark might give you a gold star. This is why the agentic harness is so important. Companies like Augment and Cognition are building systems that don't just pass tests, they actually try to break their own solutions before submitting them. They run a separate adversarial agent that acts like a hostile QA engineer.
It's like the AI needs a critic personality. One agent writes the code, and another agent may be a mean. One tries to find every reason why that code is garbage. This won't scale. This is a security risk. This is unreadable. That adversarial approach is how you get from 80% to 90%. It forces the model to justify its choices.
And that brings us back to the cost. If you're running 2 or 3 high-end models in an adversarial loop, your cost per bug fix goes from $400 to $1,200. At that point, is it cheaper than a human? A senior dev in the US might cost $150 an hour. If they can fix that same bug in 2 hours, the human is actually cheaper than a high-end agentic swarm. And the human can also explain the fix to the rest of the team in the morning stand-up.
That is the aha moment for me. We always assume AI is the cheap alternative, but at the bleeding edge of reasoning, compute is incredibly expensive. We might see a future where the AI does the boring, 70% for pennies, and the humans are brought in not because they are smarter, but because they are more cost-effective for the really complex multi-hour debugging sessions. The AI tax for high-level reasoning is real.
It's a weird reversal of the AI will replace us narrative. It might be that AI will assist us until it becomes too expensive to compute the answer. But let's look at the practical takeaways for people listening. If you're a developer or a tech lead, what do these leaderboards tell you to do today? How do you actually use this information?
For me, the first takeaway is, don't get married to a single model. If a Chinese lab like Minimax can give you 90% of the performance for 10% of the cost, you need to be using an agnostic framework. You want to be able to swap the brain out as the leaderboard shifts every month. If you're locked into the OpenAI API and Anthropic drops a GPT killer for coding, you're at a competitive disadvantage.
Second takeaway, focus on your test culture. The only reason these agents work is because there is a ground truth to aim for. If your company's code base has 0 tests and a messy structure, an AI agent is going to be useless. It will just hallucinate in circles because it has no way to verify its own work. The AI-ready codebase of 2026 is one with high test coverage and clean interfaces. You're basically writing the instruction manual for your future AI coworkers.
It's the data labeling of the coding world. If you want the AI to help you, you have to give it a map. And third, I'd say start looking at the scaffolds. Don't just chat with a model in a browser. That's like trying to build a house with a Swiss Army knife. Use tools like OpenHands, Claude Code, or Tray that actually wrap the model in a professional engineering environment. The harness is where the magic happens. It provides the terminal, the file system, and the browser that the model needs to actually be an engineer.
I'm also keeping a very close eye on the pro leaderboards. The gap between verified and pro is the gap between memorization and intelligence. As that gap closes, that's when we'll know we've actually cracked the nut of autonomous engineering. We're looking for the moment when the pro score hits 70%. That's the tipping point.
It's a fascinating time. It feels like we're watching a child grow up in fast forward. 2 years ago, it couldn't tie its shoes. Now it's passing the bar exam, even if it's cheating, a little bit by looking at the person next to it. But eventually, it won't need to look at the person next to it. It'll just know.
But hey, even a cheating genius is still a genius you can use to get your work done faster. I'll take a 79% success rate over my own misplaced backslash rate any day of the week. I'd rather spend my time thinking about the architecture than worrying about regex syntax.
Fair point. I think we've thoroughly dissected the leaderboard for today. It's a reminder that even in a world of superintelligence, the details, the scaffolds, the costs, the test suites still matter more than the hype. The who and the how are just as important as the what.
This has been a deep dive into the state of AI coding. Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes and making sure our own scaffold is running smoothly.
And a big thanks to Modal for providing the GPU credits that power this show, including the ones Gemini is using to process all this leaderboard data right now. This has been My Weird Prompts.
If you're finding these deep dives useful, leave us a review on your favorite podcast app. It really helps the algorithm find other nerds like us who want to talk about agentic harnesses at 2 in the morning.
Catch you in the next one.
See ya.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow